Alright folks, welcome back. In the last video we configured both spoke routers to have a second tunnel leveraging or going to DC1 WAN 02. So we turned our design into a DMVPN dual hub design, if you will, right? Two hubs in the data center allowing us to take advantage of the redundancy. So just to kind of confirm, right now I just did a show DMVPN on all four boxes, and you can see, 18 and a half hours ago was the time we established these VPN tunnels. So everyone should have essentially two, okay? So that's what we expect. Today what we're going to do is we're going to take advantage of the MPLS. So highlighted here we have site A's MPLS, right? Highlighted over here we have site B's MPLS. And obviously those MPLS connections go down into our data center from previous videos where we established BGP, and we kind of did that, I'll call it quote unquote, that ugly redistribution between our EIGRP in the data center and our BGP going up to the service provider. So let's jump right in. Let's jump right in and get all the tunnels built for over the MPLS. So at the end of this video, what we should see is 4 tunnels. So at a spoke site, we should see the 2 tunnels we already have, and then we should see 2 additional tunnels, which are going to be over the MPLS underlay. One goes to WAN 01, the other one goes to WAN 02. So let's jump right in. Just going to bring up some notes here because there's a few gotchas with this config. So when we did... Well, it's on the hub side. Let's just do the spoke side real quick. So let's just take a quick peek at tunnel 0. All right. So really what we're going to be doing is just kind of recreating this same exact config, but for a different tunnel number. So we'll just use tunnel 1. All right. So basically the idea that I kind of came up with here was for interface tunnel 1, okay, we're going to reuse most of the commands, and we'll tweak what we need to tweak as we go. So for the IP address, since the third octet is significant for tunnel 0, we'll change that to a 1 so it's significant of tunnel 1, okay? So we'll basically just reuse all of the other aspects of the IP address. All of this will stay, but the mappings are going to change, right? So if you recall, we need to accommodate the the private address of whatever the hub is. In this case, it'll be hub 1 and hub 2. So 1 and 2. And then this is arguably the public address or the outside. In this case, it's MPLS. So it's going to be a private address, but it's the underlay MPLS address, if you will, if that makes sense. So we're going to steal this. This will be 1.1 because it's going to go to hub 1. And then all we need to do is get his MPLS address, which is 192.168.0.2, okay? So that's what we're going to stick there, all right? And then for the next hop resolution protocol, the map multicast is going to point to that same address. If I could copy it. All right. Now we're going to create a second mapping. This is going to be for WAN 2, router WAN 2, okay? So it'll be 1.2, and then his IP address is 192.168.0.6. All right. Same thing for this 0.6. We'll use the same network ID. Everything else will be these 2 lines remain the same. And then for the next hop server, obviously we're going to repoint it to the new IP address. All right. The tunnel source in this case is going to be our MPLS interface. So if we double check that, that is Ethernet 0/3, okay? So this is going to be Ethernet 0/3. And then all of this should stay the same. All right, so let's blast that in there. So we should see a second tunnel. 1.11 and 0.11 was the original. It should not be up or anything right now. So their mappings are there when we do the show DMVPN, but they're kind of stuck in the various negotiation stages because the other side hasn't been configured. So that's fine. We'll get to that in a second. So let's do router B. Okay. So I'll move this over. Router B, show run interface T0. So same story, right? We're just going to kind of mimic what we have going on. 1.12. This is 1.1. And in this case, it was what, 192, 168. Of course, I can't remember. 0.2. And then this is going to be 1.2, and it was what, 0.6, right? Yeah. .6, same IDs, all this is the same. Next hop server 10.255, 1.1, up arrow, and 1.2. I believe so. 0.3 is our source interface, right? So 0.3. Okay, so that should be the full config on site B router 1, right? So obviously, again, we're just stuck in the negotiation phases. So let's see if we can fix that on the hubs. So on the hubs, this is where one of the gotchas comes in. So if we do a show run section crypto, just want to highlight this because this is important and this will impact whether the tunnels come up or not. So the crypto keyring. So the keyring is just a place to store the key. Okay, so think of it as like your car keys, whatever. It's just a place to attach the key to, right? So the keyring is called Cisco. That's what we did. But the pre-shared key is actually Cisco as well. So it's a little misleading because they're named the same thing. Okay, but the more important thing here is that it's attached to the VRF INET. So if we wanted to, if we were under the assumption that we were just going to reuse this keyring, right, it would not work because the WAN 01 tunnel that we're trying to establish is not part of the VRF INET, okay? So that's a key distinguishment that we need to make. So I'm basically going to rename this and we're going to create a second keyring so that they're kind of indicative of what we actually have going on. So let's just go ahead and get rid of this. So we're going to know this out. All right, so that's gone. We're going to recreate that, okay? But this time, this is what I'm going to call it. I'm just copying it from my notes here. So I basically recreated it, crypto keyring, okay? But I called it DMVPN-INET, and I just put it back into the VRF INET, okay? So the name is just a little bit more descriptive, and then this command is exactly the same. We're still saying that the address is anything key Cisco, okay? So we're going to follow suit with that same keyring, but apply it for the MPLS, okay? But in this case, all right, when we create the keyring for a DMVPN MPLS, notice we're not tying it to a VRF because the MPLS is not in a VRF. It's in the global table as far as this WAN router goes. And then obviously we are using the same key, okay? So in this case, the same key applies to both keyrings, if you will. but it's just one's attached to the VRF and one is not. All right. So that's really the big thing that's going to potentially have an impact on whether these tunnels come up or not. The other piece, if you remember, was we had to, under the tunnel 0 for the iNet, we had to tell it that it was in the VRF iNet. For the tunnel 1, we're not going to have to do that. All right, so that line will just essentially get left out. All right, so we're going to do the same thing. So most of these commands are just going to get recycled. All right, so all of this, the source is obviously going to change. So the source for WAN 01 is going to be gig 6, okay? Because gig 6 is our MPLS interface that we have established our connectivity through. So we'll say gig 6. And then we just really have to put the rest of this in there except the tunnel VRF, right? We don't want to put that in there because that will obviously break the tunnel. So let's just do a quick verification, right? So if we do do show run interface tunnel 1. Let me just make sure I didn't leave anything out or mess anything up. I believe it is good. And it looks like we may have just gotten our up message per se. Yes, we did. Okay. So that means that the config we just put in is obviously working, right? So we can see that the tunnel for peer 0.2 has now come up, and it's static from the spokes perspective, but from the WAN perspective, it should show as dynamic. Okay, so you can also see that we got our other peer from the hub side point of view because we had configured our spokes first, right? So if we do show DMVPN on site B, we can see that we have that same up status just like we do on site A. So far so good. All right. So let's just save these configs. And then we just have to do the second hub router. So let's quickly get that done. So show run, or we got to adjust the crypto, right? So you can see we have just the one that applies to the VRF iNet. So let's just take him out for the moment. And then we should be able to reuse what we have here. Okay, so let's steal that from router 1. So that's done. Interface tunnel 1. Okay, do show run interface tunnel 1. It's got nothing on it. So let's copy 0 and make the necessary changes. So 1.2, the source is, I'm going to assume gig 6. Yes, it is. I have it highlighted on the topology. We don't need the tunnel VRF, but we do want the IPsec encryption to be layered on top. So that's the other thing. I don't think I made mention of that last video or the video before, but you can take, if you remove this tunnel protection from all of the tunnels across the board, spokes and hubs, it will work. This command is there to essentially make it change it from a GRE tunnel, which is a non-encrypted kind of unsecure tunnel, into an IPsec tunnel or an IPsec tunnel. That's really all that command does. All right, so show DMVPN, check it out. That's awesome. So now, right? So now on both WAN routers, so let's make this full screen and we'll kind of compare the two hubs. All right, so when we look at the details of all the tunnels, we can see that we have 2 peers through the internet, right? That's the 200 addresses. And then we have 2 peers on the MPLS 192.168s. They're obviously the same spokes, but over a different transit. So this is really, really awesome, right? So I want to just do one more thing before, well, actually, let's just make sure our spoke-to-spoke is working. So the other thing I want to point out, so let's split A and B. So we got A and B. And just to make sure, right? So we only have the 4 static tunnels that we have configured, right? Let's do a couple pings back and forth and make sure that the dynamic multipoint functionality is properly working. Now, one thing I will say is that based on the way the next hop servers are configured, okay, if you tried to cross MPLS and internet between sites, that's not going to work, okay, because they're 2 different underlay transits. So you're not going to get a dynamic tunnel split between the 2 transits. You're only going to get a dynamic multipoint tunnel if you're pinging internet to internet, right, as an underlay, internet to internet, or MPLS to MPLS. So what I mean by that is, like, so for instance, if we ping 0.11, right? So let's ping 10.255 0.11, or 12, excuse me. 0.12 is site B, all right? So just to kind of validate that, right? So 10.255 0.12. So we're going to ping that address from site A. Okay, so we have connectivity, all is well. If we do show DMVPN, now we can see that we have that dynamic tunnel that came up as a result of that ping, okay? Let's do the same thing for the MPLS, all right? So his MPLS tunnel is 1.12. Let's do a trace route this time, 10.255 1.12. Let me make sure domain lookup's off real quick. Okay, trace route to 10.255 1.12. So when we do the trace route, look, I want to point something out. It goes to 1.1, okay, which is the hub, okay? Then it goes to 1.12. So essentially, if we look at the topology, so I'm on router 1. When I pinged that address, it went through the underlay transit to the hub, and then the hub chucked it back out to the branch site, okay? But if I show DMVPN, I have the dynamic tunnel as a result of that trace route that we just did, okay? Now, if I do the trace route again, now it goes right to 1.12, okay? So that's the proof that instead of doing hub-spoke connectivity, Next Hop Resolution Protocol took over and said, no, you have a more efficient way to get there, establish the dynamic tunnel, and then the next time you send traffic, it's going to go right there, okay? That's the whole point of DMVPN. And this is the proof that it's doing that, okay? So we can see how just in a simple topology where we have 2 spokes and a data center, we have 6 tunnels that are essentially in effect right now, okay? So as you scale this, right, you have to consider IP address schemes, you have to consider a lot of things because the tunnels will start to grow in size exponentially, right? Depending on how many branch sites you have and traffic flows and all that other jazz. So I just want to do one more thing, and I think it'll tee us up for the next video. So there's going to be one more video kind of revolving around this because all we've done up until this point with DMVPN is establish the tunnels. We haven't introduced routing. I keep saying it, and it seems like we never get there, but we're finally ready to introduce routing, okay? So on router 1, if we show run section EIGRP, we never did EIGRP from a branch perspective, okay? We had those lame static routes. So we had the IP route for the data center, okay? 10.100, or excuse me, is that site B? 10.100. what am I on? A router 1, right? 10.1. Oh, I'm sorry. This is the route to go. That's my fault. This is the route to go down to the inside. It's staring me right in the face. So all these routes, we want to get rid of some of this stuff, okay? Obviously, the track stuff, it can probably stay because that's our way of making the internet fail back over and all that other stuff. We may need to adjust some things with that. We'll see. But like this route here, you know, we ultimately want to get rid of that, okay? And if we show IP route, right, we're learning the BGP routes, okay? We're gonna essentially get rid of the BGP routes and we're gonna replace them with EIGRP routes. And I know that sounds weird, but we're gonna go through it one step at a time. The only thing I want to end with this video is to just turn on EIGRP for the DMVPN schemes, the 10255s that we just built, and we're gonna walk away from it. And when we come back, we'll look at what effect it had on the routing table, and we'll talk about what we need to do to replace BGP with all of the EIGRP. So let me stop talking and let me start doing, right? So let's do router EIGRP, and we've been calling it EIGRP AS, what was it, 65001. So since we're running 01 in the data center, we're going to have to kind of use that same autonomous system number. Yeah, 65001. So we probably should have chose, or I should probably have chose a better number, because now we're kind of stuck with 65,001 across the board. But it's just an autonomous system number. It's not really, it's more of a cosmetic thing, I guess you can kind of say. So we'll turn it on for IP address family, or address family IPv4, autonomous system number 65001. And then the only thing I'm going to do is essentially put in 10, 255, 0, and 1. They should be the two subnets that we're concerned about. 10, 255, 0, and 1, okay? So 0.1, and we're going to do a /24 in wildcard bits, that's 0000255, okay? And we're going to hit the up arrow, and we're going to just change, oops, I'm sorry, it should have been 0, that's my mistake. Let's get rid of this. And then we're going to do 1.0. So let's just make sure it looks correct. Yeah, I got to put the other statement in there. 1 dot. I need the 0 dot. Do show run section EIGRP. Okay, good. So we're just going to take this exact same EIGRP config, and we're going to put it on site B. And then for the WAN side, show run section EIGRP, we're going to just put those network statements in here. So let me just steal those. All right. And then do show run section EIGRP. One more box to do. Okay. So check it out. And again, we'll stop here and we'll kind of rip into the routing on the next video, because it might end up being like 20-30 minutes. But as soon as we did that, we have 4 adjacencies. Okay, we have 4 new neighbors that have come up as a result of turning on the EIGRP instance. So now, right, show DMVPN shows us the tunnels and the overlays, underlays. If we show IP EIGRP neighbors, we now see that we have formed the neighbors over those tunnel interfaces, which is the whole kind of point of this operation and what I wanted to kind of get to. Now, I'll point this out and I'll let you guys kind of think about it before the next video is published. The next video is not recorded yet. I still have to do that. But one thing I will point out is that we have all those neighbors, but we don't have the EIGRP routes, okay? We still have BGP routes, okay? So I'll leave you with that to think about, and then when we come back on the next video, we'll basically try to replace everything that has a B with a D, and make this network more of a flat EIGRP topology, which will be a little bit easier for us to maintain and stuff like that. So I hope you guys liked it. This is pretty cool stuff. This is some of my favorite topics here. I can't get enough of it. I just think it's the coolest thing. Anything that's underlays and overlays, I mean, that's where the networking world is these days. So if you can build a good solid base and understand these underlay, overlay, and the way they interact and how to kind of do all this, you're going to be, you'll be a dangerous person for sure. I think that there's plenty of room for network engineers out there, and I am hoping that I can excite you and show you, why it's so cool. So take care. Until next time, I will see you there.